can really determine the actual reality. What kind of results one will really see. That for that purpose, we have to really worry about force per unit area. And the best way to vector division is not straightforward. So we try to introduce something like higher rank tensor, which we call stress tensor. If I'm going to condense it on area vector, then I will be going to get force. If that I can really do that, the stress projecting onto area throughout the material, even the cycle tube and so on, if I'm going to add everything, I will be going to get overall force on the system. Perhaps that might act at center of mass. That is the way people try to link it up. Beginning like center of mass, try to really zoom in, it is not possible. So one has to really look at this material contribution. If that is the case, introduce a higher rank tensors and go ahead further, try to represent the same what Newton has done. And also we try to really look at how the summation rule really works. Great. And then we try to really construct, even if I take two tensor of rank 1, if I am going to make a product, I can really get higher rank tensor of rank 2. That also we have seen AIBJ. It's not only for that, even for typical mechanical engineers and so on, usually we write something like thermal energy equation and so on. We try to use something like diffusion coefficient. And that diffusion coefficient, we usually take something like meter square per second and so on, thermal conductivity, so on, so kind of thing. These we usually think like these are constant values and scalars. But at higher level courses, you will really see that even the thermal conductivity is not a scalar, but it is a higher rank tensor based on the material properties, how homogeneous it is, how isotropic it is. It may not be just a simple scalar value, but it is actually a tensor. Suitably, you project that tensor onto respective spaces and so on, so that one will be in a position to really get the transport properties. Okay. Now, without really going deeper into that continuum mechanics, what we will try to do is tiny examples application. We will try to see how to really interact these vectors with each other to understand what is going on. Okay, fine. Let us begin with three vectors. So let us think of three vectors. And we would like to really construct something like an easy thing, A dot B multiplied by C. Is it a vector or scalar? A dot B multiplied by C. Hello?
Vector.
It's a vector quantity.
So that's the thing what we are trying to look at even through indicial notation. So A dot B C. Whenever dot is there, that means there is a summation on the indices. A is AI, A1, A2, A3. B is BJ in the loop 1, 2, 3, B1, B2, B3. Now A vector, B vector are multiplied with each other. That means I need to construct a loop. I is equal to 1, 2, 3, AI, BI. And C might be C vector, or C might be CK, or it can be CP also. This index is just something like notation. CK means C1, C2, C3. CP means C1, C2, C3, just to indicate that we are showing. So that anyway, I can even use C as CJ. The only condition is if two of the indices are repeating, I need to really put a summation. That means the same thing I can always write it as, which is equal to summation J is equal to 1, 2, 3 AJ BJ. It can be CP also. That way also I can write it. You understand what I am trying to write? Hello?
Yes, sir.
Wonderful.
Yes,
If
sir.
that is clear, if you look at each of these things, these are scalar components. Individual entities are scalar components. So the first advantage with indicial notation is you always do any product multiplication, product or multiplication, subtraction, division, addition, all these operations, you will do it only on scalars. You don't really care about it is vector or some other thing. It naturally comes out of the system. Fine. So now if you are going to look at that, this is anyway condensed information, a single scalar, three individual scalars. That means I will be going to have I is equal to 1, 2, 3, AI, BI multiplied by C1. Summation I is equal to 1, 2, 3, AI, BI, C2. Summation I is equal to 1, 2, 3, AI, BI, C3. This is the components what you are going to get. Fine. If I would like to really do it in a standard way, it will be A1, A2, A3, B1, B2, B3, C1, C2, C3. A dot B means summation AI, BI, which is A1, B1 plus A2, B2 plus A3, B3 multiplied by CJ, C1, C2, C3, which is A1, B1 plus A2, B2 plus A3, B3 multiplied by C1, C2, C3 as a vector. Fine. Now, if you prefer it in terms of directions, then one can really write it like A1, B1 plus A2, B2 plus A3, B3, C1 multiplied by I bar plus A1, B1 plus A2, B2 plus A3, B3 multiplied by C2, J bar plus A1, B1 plus A2, B2 plus A3, B3, C3 multiplied by K bar. To avoid such kind of long big thing, usually we recommend to go with this shorthand notation. When one is going to use the equations, simplify the things and so on, we usually go with this shorthand notation rather than writing such big expression. Is that step clear? Avyaya?
Yes, sir. Yes, sir.
Wonderful. Okay. So if I put it in this way, usually at these applied math courses like fluid mechanics, continuum mechanics, and so on, people use something in two notations. One of the notation, what we call Gibbs notation or Gibbs calculus. The second notation, what we call is indicial notation. So Gibbs notation is popularized by Josiah Willard Gibbs, who is applied statistical mechanics guy in 1850s, 1870s, and so on. He was a professor at Yale University, studied from there and so on, so kind of stuff. And it was popularized by him up to 19th century. 19 mean 1900s. And for that, what he tried to do is usually he gives something like vector, underscore, dot, cross, this kind of notation he used to give. He used to work in that way. That kind of notation, what we call Gibbs notation. So earlier, +2 kind of things, what we have learned, something like dot, cross, and so on, so kind of things, we usually call at this continuum mechanics kind of classes as Gibbs notation. After 1900s, people started going with this indicial notation, where you don't really care about dot, cross, and so on. Everything you talk in terms of scalars, the values, and you just use something like index. A dot BC is AI, BI, CJ. The advantage in terms of using indicial notation is you don't have to really put something like, remember, parenthesis. You don't have to really be very careful like Gibbs notation. For example, let me show you what I mean. I'm going to put A dot B multiplied by C. This is the thing what I'm going to write. If it is in terms of Gibbs notation, You have to be really careful to write it in that way. You cannot really write A dotting with B, C. In terms of notation, one has to be very careful what they are trying to do. This is not permitted. So this kind of many rules will be there. For example, if I am going to show you A cross B dot C. Is it permitted operation? It depends on how you are going to write it. If you are careful enough, you will put it in that way or you will calculate that. If you are not careful in terms of writing, it may be interpreted by other person as this, which may be absurd. So because of that issues, people started avoiding Gibbs notation in 19th century onwards. We have to be very careful. Someone writes something, but other person understand it in other way. To avoid all these things, better to use this indicial notation. And especially these high energy physics guys and also these theory of relativity guys really jumped into that, and even quantum mechanics, it becomes so easy to follow with this indicial notation. And throughout our course, we will be happy to go with that indicial notation because there is no possibility of making mistake. With minimal care, we can really handle. If it is Gibbs notation, is big, one has to be very, very careful. Fine. So shall I move on to the next one?
Yes, sir.
Wonderful. Fine. So this is the thing what I would like to really say. The advantage with this indicial notation is we write only scalar components for vectors, tensors of anything. If I am going to write A cross B dotting with the C, the Gibbs notation, in a scalar form, if I would like to write, I can so easily write epsilon I j k A j B k C I. Everything scalar components, I will be in a position to write it. We'll see shortly. Second thing, the legality in terms of notation can be easily tracked. And in terms of thinking, programming, indicial notation becomes so easy to think or to write a program. If you want to teach a computer to remember all the Gibbs notations, rules, and so on, to code anything, products and so on, so thing, it's not that easy task. You have to teach a product something like what it means cross product. For example, let me ask you a simple question. And this question is meant for either Nishikant or Snehal. Okay, I would like to get cross product of A1, A2, A3, this one, B1, B2, B3. Can you tell me what is the cross product of that? Hello.
Yes, sir. Yes, sir.
So I would
Yes,
like
sir.
to know cross product of that. Can you help me?
Yes, sir. A2 B3
Yes.
minus A3 B2R minus A1 B3 minus B1 A3J plus A1 B2 minus B1 A2K.
Okay, wonderful. So this is the way we know. Now let me slightly increase the complexity. Hey, my vector is not three-dimensional or maybe not three components, but it has n components. Maybe A4, A5, and so on, AN, B4, B5, and so on, BN. Now I'm interested, I, J, K, M, N, P, Q, R, and so on, so kind of stuff it is going. Now I would like to have a cross product. How I'm going to calculate it? How easy it is to teach to a computer. For example, if I am going to write something like Gibbs notation, computer programming, you take vector A, you take vector B. Cross product means there might be a loop where A2 B3 minus A3 B2 plus blah blah blah, one can really do. Tomorrow someone gives you 4 component vector asking you to calculate cross product. Maybe asking you to calculate cross product for 5 components, maybe 6, 7, 8. How easy it is to program it. The same formula what we have remembered in +2 may not be that obvious to write it at the programming level or even to teach computer whenever the index changes. You see the difficulty in terms of cross product rule, what we have remembered. Hello.
Yes, sir.
Yes, sir.
Can you help me out for this n by 1 vector? How to get by standard formula to get a cross product? Who can help me? Without
So using
permutation
cyclic permutation
no,
of
I don't want to. That is the point. I don't want to use that at this starting point because we are coming from different backgrounds. So if I straight away jump into permutation symbol or alternating tensor, it becomes so obvious thing. But people may not have heard about that also. There are some people. So can you help me out? Ramana, Gangadhar.
Sir, by writing the standard definition of determinant.
Are you sure in determinant one can really calculate? But it is something like a vector product.
Yes, sir. Determinant also has similar to the one summation of the elements in the vectors. Some
Sure.
formulation.
You mean the Jacobian one has to calculate and so on? That one.
Jacobian
Okay,
matrix.
but we will shortly see how easy it is if we go with indicial notation. It looks like learning indicial notation at starting stage might be difficult. But once you learn the shorthand notation, it becomes so easy to calculate any kind of vector products or higher rank products. Shortly, we will see that. Snehal,
Yes, sir.
so are you aware of permutation symbol?
Yeah. No, sir.
Okay, wonderful. If you don't know, then it's good. If you know, then it's bad. Fine.
Sir,
Let us begin with that. Yes, someone was
sir,
saying something.
yes, sir. Can't we use the definition of cross product like A cross B equal to mod A mod B sin theta?
Definitely, but how easy it is to teach to a computer if I am going to increase the number of components from 3 to 4 to 5 to 6 to 7 to 8 and so on.
Okay, sir.
Every time there will be a control loop to really check it like what is the component size and go ahead.
Yeah, yes, sir.
Let's switch these.
So permutation symbol looks like a pi. Is the one you are saying?
We will see that. We will shortly see that. I mean, we can go very fast, but that's not the point of the course. I want to even learn with you. Fine. Let us begin. Before really jumping on to permutation symbol, how easy it will be. First, let us calculate hands-on experience with this indicial notation. Fine. So first of all, I would like to ask, is A dot B dot C, is this correct? This is Gibbs notation. Hello. The first question is to Nishikant.
Yes, sir.
Is it right? Wrong? Is it permitted? Legally permitted? At least at that math level.
First one, A dot B dot C.
That's right.
No.
No, that's the thing what we would like to really see. Because on the first front, because we already God's given knowledge or earlier framework, whatever that, A dot B dot C doesn't make sense to us because two vectors dotting, so scalar, then I'm going to again make it like scalar kind of thing. It doesn't make sense. So at initial notation, just for practice, if I'm going to look at what it means, first of all, A dot B. A dot B means summation I is equal to 1, 2, 3, AI, BI. As it is dot, I'm going as it is C. Now, this entire thing, does it contain any index? If it has index only, I will be in a position to really replace that particular dot by repeated index, bringing one more summation, K is equal to 1, 2, 3. Already condensed information, I is equal to 1, 2, 3, AI, BI in case if this entire thing have an index of k, I will be in a position to really write that there might be index k, c might be repeated in that way. But when I already summed it up, there is no repeated index. So by definition, I cannot really write that. So this one cannot be permitted legally.
Right.
Now the next question, let us ask either our Snehal or Gangadhar. Now I'm writing this one. A dot T is a second rank tensor, dotting with again second rank tensor. We will see this kind of things. So you have to really ready to face them. Is it legally permitted? This is what you call Gibbs notation. Right now what I'm showing. Now I just want to see whether it is legally permitted or not. Gangadhar, first one has to convert that into indicial notation.
After converting, it's look like again a tensor, sir. I mean second order
So
tensor.
what I would suggest is to everyone, first pick something like indices. A is represented by AI. T is represented by something J, K. Maybe D is represented by M, N. I varies from 1 to 3. J also varies from 1 to 3. K is also varies from 1 to 3. M also varies from 1 to 3. N also 1 to 3. Now carefully replace these indices by summation rules. Can you please do that for me? I have given you a hint. So let us ask either Nishikant or Pratima.
Yes, sir.
So I'm giving you hint. A vector can be replaced by AI indices. T tensor of rank 2 can be replaced by TJK. D is of tensor rank 2 can be replaced by DMN. Now there is something like dot. Step by step, go ahead and try to simplify the thing. End of the day, what are you going to get?
Sir, first parenthesis will give a second order tensor, and then dotting it with A gives another vector.
Which one are you going to do first of all? Tell me, which one are you going to do? So you would like to really dot one of the index, you would like to really replace by summation. Is that right?
Yes.
That means maybe one of them is TJK DKN. Because summation rule I'm not going to write, is implicitly summation is there. Whenever repeated index is there, I'm going to use that Einstein rule to really say that summation k is equal to 1 to 3 TJK DKN. Now this has to dot with A. That means I need to really do AI dotting with that. That means one of the index, I would like to really repeat it because K is already out of that index. So either J or N, I would like to really replace. The easiest thing what I can really connect is I is equal to J. That means what I am going to get is AI TIK DKN. What is the free index I am going to get? I is repeated index, K is repeated index, so N is free index. That means I'm going to get only one vector. Is that clear? Not clear.
Yes.
Yes, sir.
Sir,
Go ahead.
Sir, for dot product, I mean, if there was a vector, then we would have done something like A dot B, A into B transpose, and something like that, right?
That's the thing what I'm trying to say. Better not to go with Gibbs notation because it's going to mislead you. The best.
No, I mean, sir, for
Yeah.
Yeah, but for the tensor, we cannot do tensor 1 into tensor 2 transpose, something like that, because
How
that
do
will not condense it.
That's what I'm saying. Because you already saturated with Gibbs notation, this transpose of that I need to do. But in the last class, we have seen if I want to really go with a product, A vector multiplied with B vector, what does it mean? Am I going to have a dot as transpose? or am I going to construct even higher rank tensors? So the convincing is because we already have a pre-knowledge. Dot means this is a vector. I'm going to visualize something like this kind of column vector. Transpose means row vector. So I can really do that. That notation itself is faultless. It is slight ambiguity always be there in terms of transpose and so on based on how we are going to do. To avoid that kind of confusion only, what we are trying to do is indicial notation with the scalar products. There is no problem with that. Am I clear, or am I dominated you without answering you? Aviruddha.
No, yes, sir. I mean, sir, that is what I'm telling, that if we are going by the Gibbs rule, then the two tensor will not condense to a vector, like two vectors condense to a scalar if we dot product.
You can do that, but that rule we don't know. That's what I'm trying to say. Gibbs rule is not wrong. We are not going to get wrong thing, but we didn't learn that rule. How to do for tensor of rank 2 when they are going to dot. That means I have to really remember what Gibbs has said, which we didn't read it in +2. That is the only point what I'm trying to say. I'm not saying that Gibbs rules are wrong. They are perfectly valid, but that requires a lot of memorization of if this happens, how to do that. If that happens, what to be done. And on computer, what kind of loops I have to really construct. All those rules I have to really remember.
Okay.
That is more difficult thing to do than going and operating it on scalars.
Yes.
Clear, not clear?
Yes.
So the pre-notation, what we have, without completely learning the things, we just picked up. It's more like the way how media really does, like selectively you pick it and try to hide the things. That way we have learned at our +2 because I can understand the situation. A kid cannot really remember each and everything, but these are the very important rules which we try to memorize them. But we, at the same time, what I want to really say is we didn't learn all the rules of Gibbs. We just selectively picked the rule, which is slight ambiguity and also a bit dangerous. That we would like to really wipe off. I don't want to really memorize all this thing. A simple notation rule I'm going to really remember. That's good enough for me to even construct any big things. Clear?
Yes.
Perfect. So let us look at that carefully. So the A dot T dot D. First, if I would like to do AT, AI, TIJ. Now I'm showing you second way. The earlier one is we try to condense first in terms of those tensors of rank 2. Then we went ahead with condensation of vector. But now what I would like to really do is repeat the same process for other. I would like to use A dot T dot D. So A dot T means AI Tij. That means already I have condensed something like Mj of T into I is equal to M. So replace M by I. That is the first thing what I have done here. Aij, Tij. Now what is the free index here? J. Now D. Maybe if I have something like Kp. Now that J and K I have to really condense. So either J replaced by K or K replaced by J. That I have to do. So A, T, I, J, maybe M, and if I'm assuming, maybe J and M, I'm going to condense, replaced by J. So summation J is equal to 1, 2, 3, summation I is equal to 1, 2, 3, AI, Tij, Djn. So you will get with only one free index N, which means it is tensor of rank 1. Clear? Hello,
Yes, sir.
Pratima.
Yes,
Is
sir.
Pratima here around?
Yes, sir.
Wonderful. If that is the case, let me ask you one more question.
Then this product is commutative.
Because we are handling each and everything is a scalar. If you look at that, it is a value of that particular indices. Nothing to deal with vectors and tensors. Whatever within the summations are always be scalars. That is the advantage of having indicial notation. That means it will be commutative and it will be associative also. And you can have addition, you can have multiplication, you can have division. Everything is permitted because we are handling only scalars. When I replace from here to here, it means whether I condense, whether I don't condense, everything I'm going to handle only scalars. That means all those axioms like commutative, associative, inverse exists, zero exists, and so on, so kind of things really works. We don't have to worry about that. Nishikant, wonderful question. So if that is the case, now the next question is for Pratima and Nishikant. I'm sorry we are spending time because this becomes very important. Though this is very tiny part of our fluid course, fluid mechanics or perhaps advanced fluid course. But once you learn this, it becomes so easy to appreciate even complex equations. Wonderful. Now, Nishikant, the next question for you. Okay. I would like to have a double condensing on a single condensing on B. I would like to know whether it is permitted or not. Can you help me out? Both Pratima and Nishikant. Double condensation means on two indices I have to condense. Single condensation means only on one of that I'm supposed to condense. And double lines means it is of tensor of rank 2, and triple lines means it is tensor of rank 3. So just to help you out, A, Ij, D, M, N, P, B, Q. Introduce double condensation, the single condensation, step by step. Try to help me out. Hello.
Sir, in M can be replaced by J.
Which one would you like to begin with? First of all, tell me. What is easy for you? Begin with that. Whatever it is easy, begin with that. It doesn't matter which direction you will proceed. Begin which one is so easy from this second step to go ahead and start condensing it.
So D M and P and dot PQ.
Wonderful. If that is the case, let us begin with that. Oh, this equal to is not double for that, is some other. Okay, now tell me what I'm supposed to do for D, M, and P. Huh?
Q
Tell
can
me.
be replaced. P can be replaced by Q, or here Q can be replaced by P.
Perfect. It doesn't matter. Okay, so I replace. Now, what I'm supposed to do with this? Tell me. Hello.
Maybe M can be replaced by J, sir. I don't have idea.
No. Why you don't have? Because double condensation I have to do. So on two indices I have to condense. That means both I free index on N or M, J free index on M or N. One of them I have to really do. That means I'm going to really replace Aij, Dij, Bp, where repetition, and P repetition. So it's supposed to be turned out to be a scalar. No free index is there. The same thing I can always condense even it in terms of DMN DMNP BP. This is also permitted. Again, no free index, so it's supposed to give me a scalar. Fine.
Yes, sir.
Wonderful. That means we have learned a lot. This is good enough algebra to begin our course in terms of governing equations. Okay. Now let me ask you this question, because is it permitted, not permitted? A fluid mechanics force, we write it. Let us write it like U dot del grad U of U. Is it permitted or not, Pratim? Permitted. Why?
Because u is a vector, you can just write ui, and
Okay, so U is replaced by UI. Then
and the
dot
grad
is stop. Grad is grad
is
J.
yes grad j, and again it will be ui.
Are
No,
you
no,
sure?
no. I mean, I know del by del xij like this.
No, that's okay. Whether you will write del by del xj, or perhaps you will write it something like del by del xj is perfectly fine. But what is the next U?
Next will be ui.
It cannot be. It cannot be.
Does.
It has to be UK. Whenever a vector is there,
UK,
you have
UK.
to now one of the index you would like to really convert because of dot. And the dot,
Yes,
whatever you would like to really have is maybe you would like to really convert it. That means it becomes ui del uk by del xi. Or you can really have uj del uk by del xj. Because if you are going to write k as I, that means already you have something like summation rule you have already applied. That is not permitted.
yes.
So whenever you see the vectors, you have to separately write down those indices, then apply the condensation. Is that clear?
Can you repeat how you applied it on U and grad and not on U and D?
So what I would like to have is U dot grad U. Now it's up to me whether to write it in that way, or it is up to me whether to write it in that way. Is that fine? Hello?
Yes.
When I am going to convert it to index notation, it is permitted in that way. Now, what I am going to write is pick any vector. I don't distinguish whether it is U or B. So instead of U, I'm going to replace by A. Instead of this, I'm going to replace B. So it should be more generic. It should not show any distinction between A, U or P or Q or whatever. So basically U dot grad U, maybe A dot grad B also permitted. That is the way, generic way I should really write it. Now, if I am going to really think it in this way, A is replaced by AI, grad is replaced by grad J, B is replaced by BK. Is that clear? Hello?
Yes.
Yes, sir.
Now it's up
Yes,
to
sir.
me how I would like to really condense. Now the dot product, I need to really condense it. Now I'm going to really pick the next neighbor thing. It's up to me how I would like to pick. But neighbor thing is quite easy to visualize for me. So what I'm going to do is AI grad I BK. AI means UI grad I UK, which is UI del UK by del XI. Done. Clear? Hello?
Yes.
Yes, sir.
That's the way we have to condense. If you have same vectors, that doesn't mean that this is UI, this is also UI. But if you are using same thing, that means you invoke the summation already. Any repeated index means it's a summation. That point one should not miss. Okay?
Sir, in this operation, sir, we had the compulsion to associate AI with grad J, right? We could not do
Not
AI and BK
necessarily,
together.
not necessarily, because everything is scalar.
But sir,
Everything is scalar.
sir, suppose dot products with this this gradient vector means what is it called? This vector is not commutative, right? Because A dot grad is not equal to grad dot A, for example.
You mean to say that A del by del x of something,
Sir,
I
I am just
cannot
talking
really
about
write it
operator.
del by del x of AB. Agreed. I cannot really write it. I cannot really write it. That's true. But I can show that that's also permitted. I just have to take care of it. What exactly I'm trying to really do. It doesn't matter.
But sir, here if you would have done, if you would have condensed AI and BK, wouldn't it have been mathematically incorrect?
You mean to say that if I'm going to condense it on that, that will be a problem?
Yes, it will give
I
some
don't
kind of.
think so. I don't think so. Let us do that. Maybe I might be wrong also. Let us use some blue color or some other. Okay. So I'm going to condense only on indices, but not switching the operator position. So AK del J BK. This is the thing what I am going to write it. Is that right?
Yes, sir.
So that means UK del J UK I need to write. That means U1 del U1 by del X1 plus repetition is on K. So U2 del U1 by del X2 plus U3 del U1 repetition is on 2, right?
No, sir. Yes.
So this is, I feel, permitted, but let me write it down to confirm. So first, repetition is summation. So I need to be just careful with that. So U1 del J U1 plus U2 del J U2 plus U3 del J U3, right? So J is equal to 1, 2, 3. That means U1 del 1 U1 plus U2 del 1 U2 plus U3 del 1 U3 I'm going to get. So you mean to say that that has a problem in terms of writing like a vector, right? Because the next one really turns out to be del 2 U1 plus U2 del 2 U2 plus U3 del 2 U3 U1 del 3 U1 plus U2 del 3 U2 plus U3 del 3 U3, which if I'm going to write it in my general standard notation, this is U multiplied by del U by del X plus V del U by V multiplied by del V by again del X plus del W multiplied by del V by again del X I'm going to get. Is that what you mean?
Yes, sir.
I see, I see, I see. Maybe I think you must be right. You must be right. Maybe Krishna is the right person to really comment on that. Let us ask her. I never thought about that. Is it compulsory for me to really condense only next ones, Krishna?
Sir, I was looking at it only.
Or even can I really condense, but I cannot switch the operator. I cannot really move the operator from here to there to there to there, but I can still keep the operator, but I can just condense it to make sure that it will be something like such kind of combination. You understand the question?
Yes, sir. If the operator is not like changing, then I think it should give the same answer.
That's right. That's the thing what I felt. But maybe whether I made any mistake in that, what I can really do is again I recheck it and can get back to you in the next class. Is that okay?
Yes, sir. Yes, sir.
But
Sir.
at this point, I feel like it should not matter as long as I just log that operator and should not bring anything into that.
Sir,
Sir,
one
Yes, sir.
more. Okay, yes.
Yes, go ahead. But
Sir,
whether that is the case or
there
not,
is,
in next class, I will definitely show you.
sir, but
Yeah.
there is no dot product between del and b.
Yes, sir. One thing I had also the same doubt. There, I think between grad and B there should be one operator.
No, why?
Dyadic product because gradient of vector.
That's
Gradient
what I
Y should
said.
be their
Nothing like-
operator.
No, there will not be any operator. It's up to you how you want. See, for example, AB I have written here. Look at this. What kind of dot you have? A, B means you are going to increase the operator size. A, B can be exist. It's just AI, BJ. And everything is scalar. What kind of operator exists there? It's perfectly permitted.
No, sir. I mean, I am telling that since there is no operator, so we can't do the thing that you are telling.
No. These scalar rules, whatever we have learned, are independent of what kind of operators really exist. But whether I did carefully or not, that I have to really check. That anyway, I will really get back to you. But these are independent of what kind of operators really exist. Only issue, once I really put something like an operator at location, I'm not permitted to really move that operator at random location. That means u dot grad u, I can really put indices, whatever the things, but I should not really write something like u dot u grad. It doesn't make sense because now this operator acts on what? That we don't know. That kind of thing I'm not permitted. But otherwise, in terms of indices, it's perfectly fine. No issue. That means if I'm going to write ui del j uk, I can always condense it like ui del I uk. But I should not write it ui uk of del I. This is not permitted because I'm going to change the location of delta because it's supposed to act. And at the same time, maybe del I acting on ui uk maybe has different meaning because I'm going to do operation like del by del x, del by del y. That is not permitted as long as I stick with the indices, but not about switching the position. Fine. For
Sir,
scalar, it doesn't matter. Yeah.
can you repeat the part where you said A and B? You take the example of A and B, and you said that no operator is required. That part. Yes, sir. Sir, I was asking that A dot grad of B, that this grad of B, there should be operator between grad and B. I was asking
I
that.
said I cannot write it directly like this. Oh, okay. My screen is not writing anything. I said this I cannot write it.
Sir, the second A dot grad B, that line, not the
This one.
this one.
Sir,
Sir,
A dot. Okay, let me erase that. So A dot grad B can be replaced by AI grad J BK with a condensation on one of the indices. That
But if
indices.
B is a vector, then there needs to be an operator, sir. So B is a vector, then there needs to be an operator between grad and B.
No, that's what I'm saying. Why do you require operator? When you are handling scalars, what kind of operator you are trying to look at? This is permitted completely.
Yeah, we will
This
just
is
get a
completely
tensor, that's all.
permitted. This is a tensor of rank 2.
Yes, sir, that's all.
This is tensor of rank 2. You are going to increase the index. And for that, we have showed the yesterday's class. If I have something like A, B, A is a vector, B is a vector, there is nothing like that. A, B is basically you're expanding each of the sets. Clear, not clear? Hello?
Okay. Yes, sir.
That is the way we write. So we have to wipe off our Gibbs notation. Without that, we cannot learn fluid mechanics. Vector calculus by Gibbs really helps a lot. But at one point, we have to completely wipe off that notation because they're so confusing compared to indicial. Fine?
Yes.
Now the question, move on, if that is the case. Fine. It takes some time for you to practice. Anyway, I will show the notes. So again, if I would like to really do this operation, A dot TD, if I just would like to see something like A T dot D, this is the one, right? Yeah. If I would like to develop a computer program, so A is AI, T is TIJ or MN or whatever that, D is PQ or DIJ kind of things in the loop. BI is equal to 0. Now, for N is equal to 1, 2, 3, for J is equal to 1, 2, 3, for I is equal to 1, 2, 3, I'm going to calculate AITIJ multiplied by DJN. AITIJ DJN in the loop. Repeatedly sum it. How many times I have to do? Double summation I have to do. So the double summation, what I'm going to do is on I and J. When I'm going to do on I and J double summation, there will be free index in terms of Bn. So Bn is equal to Bn plus AITIJ multiplied by DJN. Repeat that. Finally, I'm going to get only one single free index Bn. That is the way you develop a program to calculate these products and so on, so kind of stuff. Clear? If someone is going to really write fluid mechanics codes, CFD codes, and so on, these operators, products, and so on, it becomes so easy for them to really do. It's just simple loops to construct it. From where to where loop exists. And we are done. Fine. That anyway you will learn in your advanced CFD courses, how to do those operations and so on. Leaving apart about that. Move on. So
Okay.
let us consider something like A cross B I would like to have. Now you realize some example what we have said. 3 components A cross B is pretty straightforward to calculate. But N components, if I would like to really calculate something like cross product, it's non-trivial task. To help that, to assist that, we have this permutation symbol epsilon ijk aibj. So any cross product of vectors means A cross B means A is AI, B means BJ, cross means epsilon ijk. What is epsilon ijk? We will shortly see, which we call permutation symbol or alternation tensor. Epsilon ijk, I varies from 1 to 3, J varies from 1 to 3, K varies from 1 to 3. So think of a computational matrix having indices ijk, epsilon ijk, you are going to define. It has values either +1, -1, or 0. Depends on what are these ijk values. If I, J, K values, maybe you are going to see epsilon 1, 2, 3. where 1 followed by 2 followed by 3. If we are going to see it in that way, that value is +1. Maybe epsilon 2, 3, 1. 2 followed by 3 followed by 1, then it is +1. Epsilon 3 to 1, you might be going to see 3 followed by 1 followed by 2, then it is +1. How about now?
Yes, sir.
So we are going to learn something about this permutation symbol or alternating tensor epsilon ijk. It contains either +1 or -1 or 0. If 1 follows by 2 follows by 3, that kind of epsilons, if you are going to see, it will be +1. Anywhere you can begin. Either you can begin at 1 or 2 or 3, anywhere. But you should go in clockwise direction. The indices, if you are going to see, that will be +1. But instead of that, 1, 2, 3, instead of that, you are going to see something like epsilon 1, 3, 2. 1, 2, 3, instead of that, what you are trying to see is 1 followed by 3 followed by t. That means you broken that order. If that is the case, the value is -1. We'll see what is the advantage. Tremendous advantage in knowing this. Now, instead of epsilon 1, 3, 2, you have epsilon 2, 1, 3. 2 followed by 3 followed by 1, supposed to see. But instead of that, you have a breakdown 2, 3, 1. Instead of that, 2, 1, and then 3. That value also -1. Maybe epsilon 3, instead of 1, you start seeing 3 to 1. Reverse the direction. That's also -1. So whatever that order, clockwise order is broken, then you will have -1. All these things when I is not equal to j is not equal to k. Whether clockwise or breaking that clockwise order, as long as I not equal to j, not equal to k, either +1 or -1. But whenever I, j, k, one of the indices, either I is equal to j, which is not equal to k. That means maybe epsilon 1, 1, 3, maybe epsilon 2, 1, 2, maybe epsilon 3, 3, 1, and so on, so kind of combinations. Wherever in the R, maybe even epsilon 3, 3, 3, maybe epsilon 1, 1, 1. This kind of equal things, if you are going to see, the value is 0. This is the shorthand notation. Once that definition is clear, now see the advantage. Even for n-dimensional vectors, what we are going to do. Can you see this screen?
Yes, sir.
Yes, sir.
A cross B means epsilon ijk ai bj. What are the indices repeating?
INJ.
I, j are repeating. That means I need to use double summation. I is equal to 1, 2, 3, j is equal to 1, 2, 3, epsilon ijk ai bj. Fine. And already we have stored or know what it means epsilon ijk. Whenever repeated indices are there, those epsilon kind of values become 0. Whenever epsilon values are in clockwise, that values are +1. When epsilon values are reverse, that values are -1. If I ever thought that thing to the computer, now look at the loop. For computer, how it really calculates cross products. For k is equal to 1, 2, 3, because that is the free index. For j is equal to 1, 2, 3, for j is equal to 1, 2, 3, free index ck plus eijk aibj end n. This loop is good enough to calculate complete cross product of vectors. Can you see this one? Hello, Gangadhar.
Yes, sir. Yes, sir.
The code says that A cross B epsilon ijk is supposed to have only free index k. So the free index is that and summation supposed to be on that ij's. That means the summation supposed to be on ij. That means the summation repeated variable supposed to be k. If this step is clear, then we are done. Is that clear?
Yes, sir.
Kuldeep?
Sir, EIJK is the epsilon IJK, you mean
That's
in the
right.
pseudocode?
Because I cannot really write something like epsilon, so I just put e.
Okay, sir. So this
Because a
decides the
program
plus or minus
level
epsilon.
writing epsilon is a bit difficult, so just like an array I have written. Fine.
Okay. Yes, sir.
Is this loop clear? First of all, if that is clear, then we can just look at very simple expansion. Now this 3 I can really replace it by something like 500. This 3 also I can replace by 500. This loop also I can replace by 500. It works one and the same. Clear? Now sometime back I have asked, if I have very big vector, what I am going to do? The same program works. I just have to specify what is that. I don't have to really worry about determinants, all these kind of calculations. Clear? The cofactors, minors, majors, all these things rubbish. You can just throw it off into dustbin. Simply use this simple loop. Is that clear? Hello?
Yes, sir.
Yes.
Only issue is we have to really
sir.
teach what is EIJK at starting of the program. Fine? Either +1,
Yes, sir.
-1, or that's the only thing. So let us look at one example, one simple expansion, and then close it, call it a day. So look
Sir,
at
just
let us.
a small doubt, sir. A cross B equals to epsilon IJK you wrote, and AI BAJ, it's fine. So then again you put summation to the in the right hand side. I mean, why summation again? I2. I mean, it's just only for value.
Repeated indices.
Okay,
B
sir.
is actually summation I have invoked for J's, and I has to be index 1, 1, 1, 2, 2, 2, 3, 3, 3, and I am going to write it when k is equal to 1. That is the loop what I am going to write it. Okay. So if I am going to really write it only for C1, E1 1 A1 B1, E1 2 A1 B2, E1 1 3 A1 B3, E1 2 1 A2 B1, plus and so on, so kind of stuff. It's just loop. I'm going to write it for C1. When k is equal to 1, I am going to write, but I and j are repeated on 1 and 3. 1, 2, 3, 1, 2, 3. Now it looks like, if I really write an expansion, it looks like that big complex structure. Computer within a fraction of a second can calculate these products and so on, so kind of thing. Already we have taught the computer, hey, E11, look at that, repeated index, make it 0. E112, make it 0. E113, repeated index, 0. E121, repeated thing, 0. E122 repeated 0. E123 non-zero survived. E131 repeated 0. E132 non-zero, so survived. E133 repeated, so 0. So it only calculates, because this computer is so fast, it knows that this value is +1, E123 is +1 multiplied by A2 B3. And E132 index is reversed. So that value is minus A3 B2. Rest of the things are naturally become 0. Computer can really do this calculation like that. Chutki mein. So it straight away calculates A2 B3 minus A3 B2. Now you want to calculate C2. Again, it does the same kind of operation by using this loop. Rest of the things become 0, where clockwise survives, counterclockwise survives, rest of the things become 0. So any big cross product, it does like that. Is that clear? Hello?
Yes,
sir.
sir. Clear.
That
Yes,
is
sir.
the advantage of index notation. Though when we are writing the shorthand notation, it looks like, why the hell we are learning new language? But once you learn that new language, comfortable with that, it becomes so easy to appreciate it. When you are going to develop extra programs, most of the times we are testers, we are users. We don't really develop the programs. But in case you want to really develop the programs, do hand-wise calculation, it becomes so easy if you learn the shorthand notation. That is the way cross products can be done. Now I'm going to give you one simple example, which you have to tell me in the next class. Okay, this for everyone. I would like to have A cross B crossing with T dotting with D. Is it permitted? Now, where you would like to put your parenthesis is up to you. What are the combinations really exist, whether this is right or wrong? This short example, what you have to really tell me in the next class. Is that fine?
Yes, sir.
Did you note it down?
Yes, sir.
Yes, sir.
Now, if that is the first example, the second example, what I am going to ask you, that also you have to work it out. A cross B double. So I'm going to replace B, dotting with T triple, crossing with C. Is it permitted? This also you have to really let me know. It looks like nonsense, but you have to really show me through indicial notation whether it really makes sense or not. If you are comfortable with computer programming or learning or revising the loops, replacing IJ kind of combination, it becomes so obvious.